Now we will continue with the test design techniques with our graph that we had before. So this is the graph, and then we were speaking about equivalence partitioning and boundary value analysis, and then decision table. Now we have state transition and then use case testing, and we will go to the experience based and structural based and so on. Now what we are doing with the state transition testing, actually state diagram or finite state machine is a good technique or well-known technique used by many other disciplines, and then it has its own discipline in mathematics, but we put our system based on this state transition, and then based on that we create a graph, the finite state machine graph, for some condition in our software, and based on that graph we will generate the test cases. Actually this is kind of model based testing because we are modeling the state of that software or a specific state of a big software, and then we generate our test cases based on that module or based on that model. Actually we will go toward this well-known technique, model-based testing, in the next module. But for now, finite state system is any system where you get a different output for the same input depending on what has happened before. So that is the state of the system. So we have a finite number of different states and the transition between these number of states. So you have states, which are the nodes, and then the transition between them. The state transition model has four basic parts: the state that the software may occupy, of course. For example, you can say open, close, these are states. And then the transition, the arrows between the states from one state to another. Of course, not all transition allowed. Sometimes you have constraints between them and so on. And you have the event or many events, of course, that cause a transition. So how a transition is going on between a node to another, a state to another. So you have to have kind of event. For example, you withdraw money or you close something or you click on something and so on in the software. And then the action that results from a transition, so for example, you do a transition, and then what will be the result of that transition? What is the action? When you click on something, you go from a state to another, and then what will be the result of that? Now, for example, you can see this graph, which is a simple finite state machine, and then this is a state transition graph, and then we have states, which are the nodes or the circles, and then transitions, which are the arrows or the lines between the nodes. And then of course you have to know that even if I have some arrows here, for example, imagine that there will be some arrow going from each card out without going to another state. So that is not a transition, basically, because a transition is happening between a node to another, between two nodes. So the state diagram here shows 7 states, but only 4 possible events. We have card insert, and then enter the pin, and then if the pin is okay or if the pin is not okay, or means that the password of the card or the pin of the card is correct or not. So if you want to design a test case based on this model or on this state machine or state transition, graph, you have two possibilities basically. The first possibility is the normal situation when the pin that you entered is okay, the correct pin, and then everything will be okay. Then you go from from start, you insert the card, and then you enter the pin, and the pin is okay, and then you go to your account, you access to your account. Or another test case is the second test case is to test whether the pin is not okay or the pin is not correct. What will happen? Then that is another state or another test case basically, and then you can generate the test case based on that. We will come back to this kind of graph because we have to cover all the states, or we have to cover all the transition between the states. So you have to specify a coverage criteria for yourself where you have this kind of graph, and we will come back soon for this in the coming slides. Also, you have kind of another thing which is called use case testing. What is a use case? Back to your information from UML, a use case diagram is a diagram that describes the use cases from the actor's perspective, from the user's perspective, for example, the user of the system. So if you have these use cases, you design test cases specifically for these use cases. So, and then based on that, you design test cases from the user perspective. And that is very, very important because you might have the greatest code in the world for your software, but when you put it online, for example, your software, it cannot handle simple use cases by the user. So the code is okay, everything is normal, you are following all the standards, you don't have mistakes in your code, but it cannot meet the use cases from the user perspective. So that is why you have to test this kind of situation also. Now, back to that software from a user perspective, there is another thing here. There is a use case scenario here. Main scenarios, main success scenario, for example, is we have extension and success, and extension means like represent the way in which the scenarios could fail, for example. So you have the pass and fail scenarios, and then the fail, sometimes we say extension. And main scenario from the actor's perspective and from the system perspective also. So you from the actor perspective, the user will insert the card, and then the system will respond to the user. So that is very important. So now imagine that you want to test this system. So as an actor, I will sit in front of the system and search for A, which is actor in this description. And then I will insert the card. So this is a test case basically. This is the first step of the test case. And what will be the action? The action will be the S, which is the system response to my step. So I will insert the card, and then the system will validate the card and ask for the pin. And then as a user, as an actor, I will enter the pin again. And then validate, the system will validate, and so on. Now another kind of testing, we have a testing method, we have test design strategy. Of course, we have the structural based testing techniques. Here you need to have the source code of the software. So that's why we call it, sometimes the books are calling it a white box technique. So here, when you have the structure, the code, you have sometimes we can use this for two purposes, basically. Sometimes we use this kind of testing or a test technique to see that whether we are covering a good amount of the code or not, or many lines of the code or not. And this is very important because if now I'm saying that theoretically, if in theory, if a test case or a set of test cases can cover 100% of the code, it means it means that we are mostly covering all the code, and then these test cases are really good test cases, are really designed good design test cases. And then sometimes we use this technique to actually design the test cases. So in the first stage, sometimes we use this technique to validate or to know the quality of our test cases. Now, we design a set of test cases based on equivalence partitioning, but when we run, we also monitor the code to see the code coverage, the code coverage, and then to see that, okay, I designed like 20 test cases, and these based on equivalence partitioning, and these test cases are covering 100% of my code. It means like these test cases are really good test cases. And then if I cover, for example, 45% of my code, it means that there is a big amount, many lines of code that we are not visiting at all by these test cases. So you have to think about it again and add more test cases probably, or think about a new design technique or new test design technique to design another set of test cases to cover the remaining part of the code. So the test coverage is really straightforward. We are tracking the number of the number of lines of code that will be executed. So the number of lines of code or items be executed actually, and then divided by the actual number of the whole number of lines of code, for example, multiplied by 100, and then that will be the percentage of your coverage. One drawback that we have for code coverage, of course, is that it measures coverage of what has been written. So the code itself, and then it cannot say anything about the software that has not been written. So basically, we can say that we have covered 100% of lines of code, but maybe these 100% of the lines of code are incomplete. So we cannot verify that, basically. So we have different kind of coverage. So if we go for coverage here, we have different kind of coverage. If we go for component testing, for example, at the system or the acceptance level, or any other level. So for example, a database structure element level, such as record files and subfiles and so on. So the coverage here means like what we are covering, and then this is very important. So for example, my goal is to cover all the partitions. So imagine that we can say, okay, we have a set of numbers between 1 and 5, and then another set of input between 20 and 50, and then another set is between 100 and 400. Now, if I choose one test case per partition, it means I am covering the 3 partitions. So it means like I'm covering 100% of these partitions. And then that's why we have a lot of coverage criteria here. If we go for percentage of equivalence partitioning, then we can say that, okay, we have partitions, and then how many partitions we are covering by designing a set of test cases. So if I design a test case, a set of test cases that cover at least, so if I choose, for example, two test cases, and then these two test cases are representing two partitions, but I have actually three partitions, so it means like I cover two partitions out of three partitions. And then also we have boundary values, and then if I, for example, I have boundaries, upper and maximum and minimum, and then I have one value above and one value um, down of the boundary, then how many of these values I'm covering. Also, how many, for example, here. So if my test case is visiting, for example, here I have 1, 2, 3, 4, 5, 6, 7 nodes. So it means I have 7 states or 7 circles or 7 nodes, whatever. And then if I if I design a test case, and then I say that, okay, my test case should visit all of them, then I'm covering all of them. Then I have 100% coverage of the states. Or I can design a test case to say that my aim is to cover the transition between them. So I want to visit all the lines between the nodes. So it depends which kind of coverage you are aiming for. So for the graph, we will come back to this coverage later on also, next module. Now, how to measure the coverage, that's tricky because in software testing, we don't use manual work, so you have to use some tool for coverage. And then when you use tools, so it means you have to do some work with that. So the tools basically, they are doing several things together. So you have to decide on the structural element or what you want to cover, and then count the structural element of items, the total number. So for example, you want to cover lines of code. Now, how many total lines of code you have? And then you put instrumentation inside your code. And instrumentation basically means like you put some other code to measure the lines of code to verify whether you are visiting any lines of code or not. And then you have to run the test cases, but also monitoring the lines of code, and that is the code coverage basically. Now, code coverage, if we are speaking about the code exactly, without going to other kind of coverage that we said, like transition coverage and so on, in the industry and reality, it is very, very rare to see 100% coverage. So basically, you can find that 60% or 75% coverage, as we said before also. So for example, in this code, that code, the first code is simple. You can cover 100% by designing some test case that can visit all the lines. So you can, if you say that, for example, you choose a value for a which is greater than b, then you visit all the lines basically. So if you say, for example, a is 12 and then b equal to 10, so that is one line, one test case, and then that test case will have 100% code coverage because you are visiting each line of them. But in reality also, it is impossible, as I said, to have 100% because most of the time, the test cases that we are designing, these test cases are visiting the same lines of code, and then you have like overlapping between the coverage or the visiting or the execution of the lines. So for example, here for this piece of code, you can say that, okay, we have a test number 1 which equal that which say that a equal to 2, b equals to 3, and then for this one, for the test case 1 the value of c will be 8, so we will cover the statement from 1 to 4 and then line 6. But for test case 1 underscore 2, which is 1 2, then the C will be 50. So we will cover exactly the same statement as test number 1. Then we can have some overlap. That is reality of coding. Another kind of coverage and another kind of test design technique that we can use is the control flow graph that we have visited before. So now I suppose you know how to construct the control flow graph, but now we want to see that, okay, we want to cover this control flow graph. So if you have a piece of code, of course, this in reality, when you have a big piece of code, it means you have to use some tool to draw this control flow graph. Otherwise you cannot do it by hand or to draw it by hand. But if you have this so you have this piece of code, and then when you translate it to control flow graph, you have this control flow graph at the right side. Now if I decide to cover this control flow graph, I have different kind of coverage, and I have to decide which kind of coverage I want to go with, and then I will design a set of test cases to cover that coverage criteria that I specified for myself. Okay, I will start from down, from the path coverage. Path coverage means you are visiting all the path that you have, all the possible path that you have in your graph. So that means during the path coverage, you have to visit A, B, D, F, H, I, which is that you can track that the graph, or A, C, E, G, I, or A, B, D, G, I, or A, C, E, F, H, I. So that is basically the graph coverage, the path coverage. And then if you have, so by 4 test cases, you can have 100% path coverage. Also, if you go for the branch coverage, you only need to visit the branch. And then if you go for the statement coverage, you only need to visit the statement, and so on. So the branch BD and CE ideally come from if then else, and then you have to visit this branch, and so on. So if you design test cases based on the graph, that will be easier, but it's a question of which kind of graph you are using. So basically, in reality, in the industry, we have some tools that take the source code and draw a graph based on that source code, and then by one click you specify which coverage criteria you want on this graph, and then when you specify the coverage criteria, then the rest will be easy. You just click, and then you will have a set of test cases based on that graph. So I will leave this table for you to track all these statement coverage branch these test cases. So for example, you have test ID, you have 2 test cases for the statement coverage, 2 test cases. So test case 1 and 2 are for statement coverage, test case 3 and 4 for branch coverage, and so on. So You choose some value here based on the branch that you want to cover, and then based on the thing that you want to cover. And then when you have that, then that will be easy because you choose some value, enter to the software, and then you have the output. Another kind of test design is experience-based testing technique. This is kind of informal testing technique, but it is very useful because, for example, error guessing is something comes from experience, and then you guess what kind of error you can have in your software, and then you can when you guess this error, it means like you can test this situation specifically to see that there is some error or not. Then there are no rules for error guessing. The tester encouraged to think of situation to drop the software basically. So there are no rules here. It's all about experience. Another kind of testing is exploratory testing, which is also very important, but it's also kind of informal. So during the exploratory testing, you use normally in industry, we use many people, more than one tester, and then we bring many people in a room, and then we give a short or briefing about how the software work. Or for example, you have a website, and then you say that, okay, dear users, this website is working like this. You give a short training about the website, and then you say, okay, now go and explore the website. If you see some problem, you have to record it. And sometimes in some advanced case, we are recording the activities that they are doing, or we are collecting data from the backlog of the software that they are exploring, and then we are getting this data and analyze the data later on. So the question always is which testing technique to choose. Basically, if you can see, each testing technique is designed for specific type of input or specific type of system. So if you choose a test technique, you can be sure at least that your system is good or will perform good for that kind of input. Otherwise, people are combining testing techniques, but also there are many factors to see which kind of that have effect to which kind of software to choose, or which kind of test design technique to choose. Basically, there are many factors. Of course, we have internal and external factors. So if you are using model-based technique, for example, if you have a model of your software, so it means the model will tell you which design technique. So if I see a model, immediately from my experience, I can say that, okay, go with that design technique. So also which kind of experience the tester have, the knowledge of the tester, and then how likely the defect is happening, and which kind of defect that you have, and then the testing objective is very, very important. What you want to test and why you want to test it, what is your objective for testing, and so on. And then which kind of documentation you have, that is very important. So if you have this kind of some kind of documentation, so it means like you have some kind of documentation, and based on that document you can design your test cases. And then which life cycle model you have. For example, the sequential life cycle model, you have to have kind of formal techniques, but sometimes when you have this iterative model, you have like informal technique. You don't need to prepare a lot of documentation for the testing. You need to engage in an actual testing process. Basically, you have also, of course, external factors. So which kind of risk that you have. For example, the safety critical system that we spoke about before. If you are testing a safety critical system, so you have to be very careful. You have to use more than one testing technique, and then you have to be very formal when you design the test cases. And then which kind of contract you have with the customer, so customer contract requirements, or which kind of contract you have. Sometimes the contract specify which testing technique to use, basically, so you have to meet the requirement of the contract. So which kind of system you have, of course, that's very important. For example, if you want to test a system for its graphical user interface, so you have a set of design techniques, test design techniques you have to follow, basically. And then regularity, um, the requirement, basically. um, for example, some industrial partner, they have some standards, so you have to follow this standard, you have to follow these test design technique, whether you are happy with those techniques or not. And then, of course, if you have time, you can invest more money for testing. You can try many test design techniques. But if you don't have time, it means you don't have budget also. Then you have to be very efficient for your testing, and then you have to use the most relevant, the most efficient, and then the most effective test design technique for testing that system. Finally, if you design this set of test cases, you have to run, you have to implement them, and that will happen during the implementation, the test implementation. You have to record the procedure, and then you have to have some script and so on. So you have um, to know which kind of script you have. And then basically, when most of the test implementation strategies are automated nowadays, you have to know that. And then when you generate the test cases, basically we have a lot of platforms that generate, that scan the input, generate the test cases, and run the test cases. And now we have a new area, which is repairing area, that you have a testing strategy that scan the input, for example, generate the test cases, run the test cases, verify the test cases to see which test case pass or fail, and then where localize the fault that discovered, and then go and fix these faults also, all by one click, for fully automated testing. And then that is the dream, and then we are searching for this kind of testing in the future, and that is the future of testing, automating everything. Test automation is in fact a big area of research, and then there are many work there. People are investing a lot of money in the industry also. So this is a simple example how to implement marketing campaign for mobile phone company, for example. Then this is kind of a screenshot of the test case 3, for example. So you have this procedure, you design these test cases, and you run them or implement them. Thank you very much. See you in the next module.